All right, today I'm going to be talking about evaluating phenotype algorithms using PheValuator. So just to make sure we're all on the same page, I'm going to give some definitions, for a case, what is a case definition, and phenotyping algorithms. And I'm getting this from a paper from Overby et al. From Jamia 2013. So a case definition describes characteristics that a patient must possess to have a disease from a clinical perspective. An EHR phenotyping algorithm is the translation of the case definition into an executable algorithm that involves querying clinical data elements from the EHR. So we have this tendency to equate the clinical definition, the case definition, with the phenotype algorithm. But we have to remember that that algorithm is actually a coded approximation of the case definition. The case definitions must be translated into these algorithms for working with observational databases to be able to query data from it. And inevitably, you're going to have a loss in the translation from going from the case definition to the phenotype algorithm. Then the question is, how much of that loss, how much inaccuracy is brought into play, and then we need to validate these algorithms, and that's why we do it. So we talk about validating an algorithm. We start off with the phenotype algorithm. And with the phenotype algorithm, you have subjects that are either included in the algorithm or not included in the algorithm. And then alternatively, you have the case definition. And the case definition gives you people who are cases or non-cases for the health outcome. And when you have these two things, then you can have this confusion matrix, this 2x2 table, that gives you the true positives, false positives, the true negatives, and the false negatives. So for instance, the true positive is when a subject is included in the phenotype algorithm and is also a case based upon the case definition. To get a complete validation of the algorithm, we need four things. We need to get the sensitivity, which is the true positives over the true positives plus the false negatives. The specificity, which is the true negatives over the true negatives plus the false positives. The positive predictive value, and the negative predictive value. So in the past, many research studies have attempted to validate phenotype algorithms. The traditional approach utilizes chart reviews of patients by clinical experts. This approach is very time-consuming and very expensive. At the end, you generally only end up with a determination for positive predictive value. What we needed to do, and what we had been working on, was a replacement that could do this validation quicker, easier, and produce actually all the elements that you need for true validation: sensitivity, specificity, etc. That's why we've developed the PheValuator tool, which is in the OHDSI tool stack. To give you an overview of the PheValuator process, it starts off with the phenotype algorithm that you want to evaluate. From there, you start by training a predictive model. You take a large random sample of patients and apply that trained model to that random sample of patients. And from there, you get what we call the probabilistic gold standard of patients. And using that, using that probabilistic gold standard, we can then evaluate all the performance characteristics of the algorithm: positive predictive value, sensitivity, etc. Let's go into a little more detail. So what you do first is you create a subject population of both cases and non-cases for the diagnostic predictive model. You extract their health data using feature extraction from the overall population, both for the cases and the non-cases. And you use a regularized logistic regression model, LASSO, from the PLP package to develop a model to discriminate between cases and non-cases. You then use the model to determine the probability of subjects having the health outcome. So in this case, you might take 2 million subjects, apply the model to those 2 million subjects, and get a set of 2 million subjects where you know the predicted probability for them having the health outcome of interest. Once you have that large population, you can then evaluate the phenotype algorithm. And one of the advantages this gives you over traditional is that in traditional validation, we talk about that you can basically get positive predictive value very accurately, but you can't get the other parameters very well. And sensitivity is especially important. What this does is allow you to get both the cases and the people that you caught within the algorithm and the people that you missed within the algorithm. Give you an example of the results that we might see. So this is an example that we see for Crohn's disease. So PheValuator can run across multiple databases and look at multiple algorithms that you might have for those different databases. In this case, we have a single-coded prevalent algorithm and a dual-coded prevalent algorithm, one where you look at it for a second code at a different period in time. From there, you can see all the performance characteristics, for instance, sensitivity, positive predictive value, specificity, and negative predictive value, plus the 95% confidence intervals. So, for instance, for this, you see in the prevalent case where there's a single code, you have higher sensitivity than in the narrower definition where you require 2 codes. So you have a lower sensitivity here. But the payback is for the narrower definition, you have a higher positive predictive value compared to the single-coded definition. And this is the information that PheValuator can give you. To get access to PheValuator, it's on the OHDSI GitHub site, and the link is at the bottom here. And I guess we're going to be given the slides at some point, so people will be able to get the link and download it and install it. And within that page, there's also instructions and vignettes and things like that that you can get a good feel for how to use the tool. There are limitations to the tool for valuing phenotypes. For one, it's only as good as the data. So PheValuator estimates the probability of the health outcome similar to a clinician would. So if a clinician had a poor set of data to be able to review incomplete chart records, so for instance, the data was sparse, they would not be able to give a very good assessment of whether a person had the health outcome or did not have the health outcome. And it's the same thing here. If our data is sparse within the data set, PheValuator also can't do a good job in predicting. Some diseases are poorly differentiated from others. So certain diseases might have similar symptoms and treatment, so that the diagnostic testing is weak or non-existent. In this case, PheValuator also might have difficult times differentiating between some diseases. Some dermatological diseases are like that. You know, psoriasis and eczema may be difficult to differentiate. Some examples where PheValuator has been applied in the public domain. In our PheValuator article, we looked at myocardial infarction, ischemic stroke, and a couple of chronic diseases, atrial fibrillation and chronic kidney disease. At ICBI, we reported on pulmonary arterial hypertension and chronic thromboembolic pulmonary hypertension. At OHDSI Symposium, we've looked at acute renal failure, kidney stones, renal cell carcinoma, and several others. Plus, we've done a ton of work internally within Janssen on a bunch of other health outcomes.